Good afternoon, students. Today we are going to look into what is correlation, and we are going to try and understand Pearson's product moment correlation and Spearman's rank order correlation. And this is a small introduction as to what correlation is. It is trying to understand the association between two quantitative variables, okay, and correlation coefficient number that you get is always between a range of -1 and +1, okay. So your correlation number is not going to go above 1, either positive or negative, okay, and it indicates the strength and the direction of the relationship between variables. Example, let's say the as time increases, age of a person increases. So the two variables in the statement were time and age, okay. Then it reflects how similar measurements of two or more variables are across a data set. So if you're trying to find out in general a particular concept, example, height of the students of your class, you want to find out whether the nutritional input that you take or the nutrition that you have on a daily basis has some effect on the height of the each and every student of the class. So first you take the average, you will find out what is the minimum height or the maximum height that is there in your class. Then you're going to see what is the nutritional intake of all the students. Then you're going to do a try to find out the relationship between these two variables by doing correlation, okay. And correlational coefficient is a descriptive statistics if it is to summarize taking from the sample data. But if it is a relationship between two variables, it is called a bivariate statistics. And if it is more than two variables, it is a multivariate statistics, okay. And if it is based on the sample data, you need to do an inferential statistic to generalize the results to the population. All right. The next thing we're going to look into are the types of correlation. We have already discussed this in the class, but I'll repeat it for the ones who have missed it out. So the first one is called the positive correlation, and +1 or -1, either of it indicates perfect positive or perfect negative correlation. So positive correlation means that when one variable increases, the other variable also increases in the same direction, okay. Meaning, example, time increases, age increases. It's a positive correlation, correct? You all agree, as time increases, age of a person also increases. All right. So that is about perfect positive correlation. The second one is perfect negative correlation. Negative meaning when one variable increases, the other variable decreases. Just for the sake of an example, I will say when time increases, beauty of a person reduces. Okay. Just for the sake of an example, that is normally not the case. So when one variable increases, the other variable decreases. Zero correlation means the number 0, there is no relationship between the variable whatsoever. So as you can see in the picture, positive correlation means everything is aligned together, it goes in the same direction. Zero correlation means it's all scattered, there is no meaning or relationship between the variables. If it is a perfect negative correlation, then when one variable increases, the other variable decreases, okay. Now we look at the correlational interpretation or the range. Okay. So if it is 0 means it is negative, or it is there is no let's say correlation at all, 0. 0 to zero point 0.3 is a weak negative correlation. 3 to 5 is 0.5 is a moderate correlation in the negative. -5 to -7 is a strong negative correlation. -7 to point -9 is a strong correlation, okay, very strong correlation or a high correlation. And -1 is a perfect negative correlation. Same way to the positives here. So 0 to 0.3 is a weak positive. 0.3 to 0.5 is moderate, 0.5 to 0.7 is strong, 0.7 to 0.9 is a very high or high correlation, and +1 is a very strong positive correlation. Okay, so the first one we will see is Pearson's R. The Pearson's product moment correlation describes linear relationship between two quantitative variables. And as you can see, this is from your record itself. The R, okay, Pearson's correlation is represented by the term R. So R is equal to summation xy divided by square root of summation x square summation y square, or you can see what each of these means. So x is the deviation of each square from the mean, y is the deviation of each square from the mean on test y, x square is the square deviation of test x, and y square is the squared deviation on test y. So this I'll explain with the help of the example given in your record. Okay, so there are two, this is the question, okay, the example. There are 5 students, marks obtained mentioned here. Okay, marks obtained in test X and test Y. If I'm replacing X and Y with English and Maths, okay, remember that. Okay, test X means English, test Y means Maths. Okay, so determine whether correlation exists between the marks obtained in English and marks obtained in Maths. Okay, so these are 5 students and their marks obtained for English and for Maths. This will be the only part of the question that you're going to get. Okay, now what you need to do first is you need to add the total marks obtained for both English and for both Maths and write the total. And then you're going to find the mean. How do you find mean? The total divided by number of participants. So 200 divided by 5, you're going to get 40. Okay, as you can see in this example. Then what you're going to do is you're going to calculate x minus m and y minus m. X means the data that you see here. So for English, you can see first data is 50, second data is 60, and so on. So over here, you can see the mean obtained was 40, correct? So we are going to do x minus the mean, that is 50 minus 40. Okay, so 50 minus 40, I got 10. Next, I'm going to do 60 minus 40. I got 20. Then I'm going to do 30 minus 40, which is a negative sum. So I'm getting minus 10. 40 minus 40, I get 0. 20 minus 40, I get minus 20. Okay. So likewise, I'm going to do the same thing for y also, which is y minus m. The number obtained here for y, the first mark minus the mean that is given. So 40 minus 40, I get 0. 60 minus 40, I get 20. Likewise, till the last, I'm going to calculate these data. Correct? Now, x minus m is what? X only. Y minus m is what? Y only. So now you're going to simply square these two columns, x and y. So 10 square is 100. 20 square is 400. Okay. 10 square again, minus 10 into minus 10. As you all may already know, minus into minus gives you a positive data. So you're going to get plus 100. Like this, I'm going to calculate my x and the y square, and I will be totaling that as well. Okay, x and y square I have totaled. Then you see xy. Xy means what? 10 into 0, 0. 20 into 20, 400. Minus 10 into 0, 0. 0 into minus 10, 0. Minus 20 into minus 10, 200. Okay. So like this, xy also I'll calculate and I will put the total it and I will add it here. So far, I hope it's all clear to you all. Okay. Now, what am I simply going to do? I'm going to substitute all the values I obtained in my calculation. So what was the formula once again? Let me just go back 1 minute. Okay. So formula was showing summation xy divided by square root of summation x square summation y square. Correct? Yes. So the next one, you already saw xy, the whole thing you calculated. Summation xy means 600. Okay. Square root of summation x square. Over here, we've already calculated. So this is 1000. And summation y square, here again you see 600. Correct. So I'm simply substituting these values into my formula. So I get summation xy divided by square root of summation x square, summation y square. I substitute my data. I'm going to get an R value like this, 0.77. If you remember, 0.77 has a very high or a very strong correlation, correct? It's a positive number, so it's a very high or a very strong correlation. So when you're writing any answer, it should be followed with the interpretation. So here you can see high correlation, meaning what? The tests, the scores obtained on English and marks are highly related. Okay, that is the meaning. So like that, you need to write your interpretation, and this is only for Pearson's product moment correlation coefficient. Okay, once again, Pearson's product moment, you are going to find summation xy divided by square root of summation x square y square. You are going to look at what data is obtained. You're going to total it and find the mean. Then you're going to in minus or subtract the data and the mean. Okay, so you get x and y, then you square it, and then you also multiply x into y. Okay, you're going to sum it all up together and substitute the same into your formula. Okay, so this is one sum I want you to try by yourself. You need to calculate the correlation coefficient using Pearson's product moment for this question. So ages of 6 people and their weight is given here for all the 6 people. I want you to calculate the correlation and say whether both are related or not. Okay, you can pause over here, take a paper and a pen and try to solve it out. Okay. Once you're done with it, please message me in the group or personally. Either way is fine for me. If I know the answer to the question, if you're getting the same answer and the same interpretation, you get 5 marks. Okay. Otherwise, you lose 5 marks, just like that. So don't mess up this question. Okay. So this is all about Pearson's product moment correlation. Another one that you have written down is Spearman's rank order correlation. Okay, so the next one is Spearman's rank order, and Pearson's product moment is written by or indicated by R, and here product moment, rank order is indicated by rho. Okay, so it looks like a P, as you can see in this picture here. It looks like a P, but it's not a P. Okay, fine, it's a symbol. So it's pronounced as rho. Okay. In rank order given by Charles Spearman, what is done is you are going to rank the data that you get in its increasing. So it's already written here in its increasing order, that is from the lowest to the highest. You're going to arrange the data and you're going to rank it. Okay. And then you're going to substitute all the variables, or let's say all the values you obtain into this formula. The formula is rho is equal to 1 minus 6 summation d square divided by n into n square minus 1. The meaning of all this is mentioned here. Okay, so this is the same question that you have written down in your record. So find the correlation coefficient by rank order method for the following score. So only up till this marks obtained is part of your question. Okay, so this is the marks obtained for psychology and sociology for 10 people. It's given here. Okay, so what you need to do is, even though they have set it as a lowest to highest, you need not rearrange ABCD marks obtained in the lowest to highest order. You just need to rank it. Okay, so if I'm looking at the marks obtained for psychology, the biggest number I am finding here is 80. Okay, biggest number I'm finding here is 80. So I'm going to start with 80 for now. Okay, I'm going to give 80 the first rank because it is the highest number. Okay, so highest number is 80, so I'm going to put it 1. So I've written here 1. Okay, then the second highest number, if I'm going to look at it, showing me as 70. Okay, so I'm going to rank it as 2. Okay, third highest number, let me see, after 70, 65. Correct? So I'm going to rank it as 3. Fourth is showing as 64. So like this, if I look, the last or the least number I'm going to get is 35, which is ranked as 10. Okay, so I'm going to rank it for both the marks obtained in psychology and sociology. Okay, from the highest to the lowest in this order. So when I say highest to the lowest becomes easy for you when you are ranking it, because 80 is the biggest number here and 30 is the smallest number. So once I have done the ranking, it is very simple. I just need to minus these two values. Okay, 7 minus 10, I get minus 3. 4 minus 5, I get minus 1. 3 minus 2, I get 1. Like that, I'm going to just subtract the values of psychology with sociology with psychology, and then I will multiply it. So once D is obtained, okay, D is difference. Okay, once the difference is obtained, I'm going to square it. So I get 3 into 3 9, minus 1 into minus 1 1. Okay, like this I'm going to get the calculation, and my summation D square, my total of the D square becomes 16. Okay, as per the data. Now rho is equal to, I will substitute all the data I have obtained. 1 minus 6 into 16 divided by n over here is 10, correct? So 10 into 10 square minus 1. So as you can see, it is substituted here. So I'm going to get the final correlation or the rho value as 0.9. 0.9 is very high, correct? Very high or very strong correlation. So interpretation says highly correlated or highly significant. With the knowledge of ranks in psychology, it is possible to predict rank in sociology as well. So this is how they are saying that these two variables, that is marks obtained in psychology and sociology, are related. Okay. So this is how correlation is found out using Spearman's rank order correlation coefficient. I hope this is clear. If you have any doubts, please read through, check through once again. Okay. Make sure you learn the formula. Don't confuse it. Once again, rho is equal to 1 minus 6 into summation D square divided by n into n square minus 1. Okay. Once this is done, try out. I want all of you to try out this question. Okay. Try out this question. Yes. So here it is given, marks given by two referees in a competition. Okay, I want you to first find out the rank. So rank order means simple. You just rank the numbers given to you in order. Okay, from highest to the lowest, and then you find the difference between it and square it, and the same thing you substitute into the formula. Okay, so here also I know the answer to the question. Once you are done with it, with the interpretation also, I want you to message me the response. Okay, so I hope you're all clear with what is or how we can calculate Pearson's and Spearman's correlation. Okay, all the best.